Good afternoon, class. Here's the final exam review covering chapters 2 and 3, the first part. And here's a pledge. Before starting the exam, please read the following and follow the pledge. I pledge on my honor that I don't receive any helps from any area. That's really the bottom line. Reminding you of various formulas. Everybody is by now comfortable with differentiation formulas and dealing with trigonometric functions, power rules, product and quotient rules, chain rule, exponentials, logs, inverse trigonometric functions, delta y versus dy, linearization, all of the above. Logs and what they mean, all we have to do, pay attention to this arrow. Log x base b equals y means b to the power of y equals x, as long as b, the base is positive and it can't be 1, giving rise to these properties. For common log, the base is 10, and for natural log, the base is e. And here's the graph giving us the relationship between exponentials and logarithmic functions. They are inverse of each other and therefore symmetric with respect to the line y equals x. This is the change of base formula. And of course, if this point represents 1, 0, if you go to the left of it between 0 and 1, natural log is negative. Beyond that, natural log is positive, and these are logarithmic properties when it comes to differentiation. So we should be comfortable with those. And the reverse process is the anti-differentiation or the integration. And this is the FTC. We have two of them. The one that says d dx of the integral of a to x f of t dt is f of x. In other words, integrate, differentiate the result, you get the function back at the upper limit. And the definite integral, which is the number, the integral of a to b f of x dx is capital F of b minus f of a. And here's the substitution. And now let's quickly remind everybody of a few things we have seen. So the graph is given. And we are interested in finding the limit of g of x as x approaches 2. Therefore, we look at one-sided limits, reminding everybody, limit of f of x as x approaches a from the left equals L, and limit of f of x as x approaches a from the right is L. Therefore, the limit does exist. So we are interested in the limit for number 2. So we're going to go from the left and the right side. Here's the left side, moving this way, moving towards this hole. The answer is 3. From the right side, putting us in this branch, moving this way, giving us number 1. Are the two the same? The answer is no, the limit does not exist. We're going to do the same thing with number 5. And that's why we're going to look at the one-sided limits. As we look at 5 from both sides, we see that we are coming towards the same hole, having a y coordinate 2. Therefore, the limit of g of x as x approaches 5 exists, and it's equal to 2. Okay. To add a couple of things here, notice the g of 5 is almost 1.4, which is not equal to the limit. So the limit does not exist. It still makes it discontinuous at this point. Reminding you the definition of a continuity indicates the limit of f of x as x approaches a equals f of a, then g of x is continuous at a. And is g of x continuous at 5? The answer is no. Can we fix it? This is a removable discontinuity because the limit exists, and all you have to do, redefine g of 5 and set it equal to the limit value 2. Whereas number 2, the discontinuity is a jump, and besides that, g of 2 is undefined, and that's not a big deal. But the fact that it's a jump, the limit from the left and right are different, the limit doesn't exist, it's not fixable, there's nothing we can do about that. All right, over here, I'm going to remind you of definition of a VA or vertical asymptote. When the limit of f of x as x approaches either a or from the left or right is negative or positive infinity, the equation x equals a is the equation of a vertical line. Therefore, for this function as x approaches 2, whether from the left or right, both of them going down to negative infinity. For 5, both sides going up to positive infinity. But negative 3 depends if we are coming from the left side. Negative 3 from the left takes us down to negative infinity, and from the right up to positive infinity. And therefore, according to this, x equals 2, x equals 5, x equals negative 3. Those are vertical equations of vertical asymptotes. Bear in mind, this is very straightforward. Both of them refer to x equals negative 3 being the asymptote. All right, so the next thing is, how do we find limits, algebraic limits? Basically, you plug in and you observe. So what happens? It results in some number, you're done. It results in 0 over some number, it's 0 because the denominator is not 0 when we write some number. If it's the other way around, you have to just figure out infinity or negative infinity. However, most of the time in calculus, we end up with indeterminate forms. Examples would be 0 over 0, infinity over infinity, infinity minus infinity. All right. If we plug in here, if we replace the x with infinity, we end up with infinity over infinity. So what is the technique? The technique, when you're dealing with a rational expression, even a fractional expression, when x is approaching infinity, then to divide by highest degree term in the denominator, namely x squared. As you can see, since x approaches infinity, this goes to 0, this goes to 0, the answer is 2. However, a good idea always is to simplify if we can. So we are going to factor this into 2x times x plus 4 over x plus 4 times x minus 4. And now if you work on that, now again, x approaching infinity, you divide by x this time because that's the highest degree in the denominator, giving you, of course, the same result. Okay, so it's pretty straightforward, everybody. If we plug in, we get 0 over 0. The technique is always factoring, so the factored format is already there. If you plug in, this gives you minus 8, this gives you minus 8, the answer is 1. What about here? It so happened that if you work it out just the way it is, if you plug in, you do get 0 over negative 16, which is 0. If you work out with the factored format, we get 0 over minus 4, which is also 0. So either way, it works out. And what about here? Please understand that we are going to go with the factored form. And in both cases, please understand the numerator is 8, the denominator is 0. However, what is the difference as x approaches 4 from the left or 4 from the right? The numerator, 4 from the left is like 7.2 times 3.9999. It's 7.9999. That's the result. So every number, both sides have the same sign, positive or negative. So it really doesn't matter. But the only number that both sides are different is 0. 0 from the left is negative, the right is positive. So you have to actually plug in. So the way I would do that, I would plug in here, and 4 from the left, let's say 3.9 minus 4, and it gives me negative 0.1. So it is 0, but 0 from the left in this case. So it's negative infinity, whereas here, let's say 4.1 minus 4 is positive 0.1, and therefore 8 over 0 from the right is positive infinity. So that's the difference between the two, and you want to be very careful of that. Over here, t is approaching infinity, you plug in, and I hope you see that according to negative exponential rule, e to the power minus m is 1 over e to the power of m. So e to the power minus t is 1 over e to the power of t, and therefore this is 1 over e to the power of infinity, which is 0, and so we get 12 over 4 over 3. For part B, if you plug in e to the power of t takes us to infinity, and the denominator is infinity, the answer is 0. In this case, because t is approaching negative infinity, I hope you see these two become identical. And we get number 3. For this one, you just plug in and you get 12 over 7. Let's switch gears as far as differentiation. I want to remind you, if the numerator is a number, you don't have to do quotient rule. Just bring it up. And now you're going to go with the extended power rule, which means 12. So f prime is 12 times negative 1 times the same thing to the power of negative 2 times the derivative of the inside, 3 e to the power of t. And so I hope you see that there the answer is a fraction bar. This with exponent negative 2 goes down, becomes positive 2. 12 times negative 1 times 3 e to the power of t is minus 36 e to the power of t, and we are done. All right, you're dealing with an exponential in the numerator and the denominator, but nevertheless, you're dealing with a fraction for part A, and so it's infinity over infinity. Part A. And the technique is to divide by the highest degree term in the denominator. This is not a rational expression, so you divide by highest value in the denominator, which is e to the power of 3x, and you try to simplify. I hope everybody's okay with this. And of course, as x goes to infinity, this is negative exponent. Each one goes to 0. The answer is 1 over 1, or simply. This one, if you plug in, you get 0 over 0. It's a complex fraction. The technique is LCD, which is 4x. So you multiply everything by 4x. So what happens? First, the denominator, x plus 4 is a problem. Don't ever distribute. Just keep it as a product. Multiply these two, and you get x plus 4. We cancel each other, plug in, and we get negative 1 over 16. All right, now we are dealing with a case that when we plug in, we get 0 over 0. And the technique, when we have a case like that, is very simple. Multiply by the conjugate, because a plus b, a minus b, their product is a squared minus b squared. So anytime you have a square root, the technique is that. So having said that, what is the conjugate of this? The same thing with the plus sign. So you're going to put it at top and the bottom, because you can't multiply by it. You have to multiply by 1. So the top and the bottom must be identical. We do that. So having said that, the denominator remains as a product of h and square root of 1 plus h plus 1. The numerator is the square root of 1 plus h squared minus 1 squared. This is what we get. 1 and negative 1 cancel each other. H and H cancel each other. And now you plug in, you get 1/2. So very straightforward, everybody. All right, is g of x continuous at x equals minus 2? Why not? And so the first question is, why are we asking for that? This is a piecewise defined function. The top and the bottom piece, both of them are linear functions, which means they are continuous from negative to positive infinity. Therefore, this is continuous from negative infinity to negative 2. This is continuous from negative 2 to infinity. You have to check the endpoint by continuity checking. Therefore, we are going to go with 3 things. We're going to start with the functional value. So wherever we see equality, so that piece is used, plug in, get negative 3. We're going to look at the left and right side. So left side, we go with the less than, and so we look at this piece. We plug in. These two cancel each other. We get negative 1 plus 3 is 2. And the right side, larger than, so we have to go with this piece. Do the math, we end up with negative 3. Clearly, the limit of the function g of x doesn't exist because the limit from the left and right are not the same. Therefore, it's not continuous at x equals minus 2. So you're done with the question. However, is this function continuous at x equals minus 2? From the right, I hope you see that the functional value and the right side limits are the same. So the answer is yes. Nevertheless, it doesn't change the fact that the g is not continuous at x equals negative 2, okay? All right, find the limit, and by now you have various techniques. You can go with any techniques, but if we stick with what we have, let's write, remember cosecant is 1 over sine. So we're going to replace that with 1 over sine, so it becomes the denominator. What you should notice is this. I'm going to change this to sine, and this is sine of sine x over sine x, and I'm going to change the x to sine x. Why is that? When x approaches 0, so does sine x. And if these 3 are identical, we can change it with theta, and therefore the answer becomes 1. It's important to see that they must be identical, okay? What about this one? Again, we notice we can, play with this and make it look like what we know already. So this you can't change because it's the argument of sine, as we couldn't change this one. So we can see that this is not the same. It's supposed to be x squared. So make it into x squared. How? Multiply the bottom by x, but you can't just multiply the bottom. You have to multiply the top by x also. So now we have the limit for this piece and the rest of it. Now, obviously, the first one goes to 0, and notice, x approaches 0. Because x approaches 0, so does x squared. These 3 must be identical. This is 1, this is 0, their product is 0. So that's the process by which we can easily see the answer. If 2x is less than or equal to g of x less than or equal to x to the power 4 minus x squared plus 2 for all x, evaluate limit of g of x as x approaches 1. So I want to remind you of the squeeze theorem. If f of x less than g of x less than or equal to g of x less than or equal to h of x. In other words, g is sandwiched between the two. When x is near a, x possibly at a, and limit of f of x the left side function as x approaches a, equals limit of h of x as x approaches a, the right side function equals L, then the middle one has to have the same limit. So let's look at this one and this one as x approaches 1. I hope you see this is 2. We're going to do the same thing with the right side. We also get 2, and by the squeeze theorem, you have to mention why the limit is equal to 2 by the squeeze theorem. That is extremely. What about this one? We want to prove this limit is 0. Let's start with a known fact. Remember, sine and cosine are between -1 and 1. Now, we want to make it look like this. Sine alpha is between -1 and 1, so sine of 2 pi over x must be between -1 and square that, so square both sides. This becomes sine squared, this becomes 1. Now, -1, if you square it, becomes 1, but you have to go with 0. It's important to know that really 0 is in between. And from -1 to 0, when you square it is between 0 and 1. From 0 and 1, the same thing. It's important to know. If, for example, it's between 2 and 5, then this both of them are positive, then this becomes 4 when you square it, this becomes 25. When it's negative, you have to consider the 0. So having said that, this looks like that. We want to add a 1 because it does have 1. So now when you add 1, this becomes 1, this becomes 2. Let me erase my word. Remember, ultimately what you want to do, you want to make it look like that. So let's multiply both sides by square root of x. As you know, if you multiply by a negative number, it flips over. However, x approaching 0 from the right is a positive value. And this looks exactly like that. Okay, so we're going to look at the left side and the right side. As you can see, both the limit would be 0 by the squeeze theorem. The limit of the given function is 0 by the squeeze theorem. All right, we want to find this limit, and you notice that this is x cubed. This would be, if you could take it out, it would be similar to x cubed. However, here's one method. Take x to the power of 6 out inside the radical. Don't move it outside yet. Reminding you, square root of x squared equals absolute value of x. That means x, if x is larger than or equal to 0, its opposite if x is less than 0. Please understand, minus x doesn't mean negative. It means the opposite. It means actually a positive value. So odd exponents such as x or x cubed, in case of the limit, as x approaches infinity for x larger than 0, absolute value of x squared is absolute value of x equals x. If x approaches infinity, you can drop the absolute value. But if it approaches negative infinity, you can't. You have to keep the absolute value, and then you drop it, it becomes minus x. That's according to this. Same thing for x to the power of 6, because when you take it out, the exponent is odd. So when I take it out, the exponent is odd. I have to keep the absolute value. And again, square root of x to the power of 6 is x cubed if x is positive. In other words, if it approaches infinity, you don't have to worry about it. But it's minus x cubed when x is less than 0. What is x? Less than 0. X approaching negative infinity, you have to change the absolute value to minus x cubed. Now, if you divide the top and the bottom by highest degree term, namely x cubed, what happens? Well, this goes away, becomes minus the square root. This becomes 2 over x cubed, but this becomes -1. Obviously, when x approaching infinity or negative infinity makes no difference. This goes to 0, this goes to 0. So the top is 4 under the radical, comes out as 2 minus 2 over minus 1, meaning positive 2. So that's the methodology. We want to differentiate this. We're going to use the quotient rule f over g, and we're going to go with f prime g minus g prime f over g squared. So f prime, the derivative is cosine x times the bottom x plus cosine x, minus g prime, which is 1 minus sine x, times f, which is the top, 1 plus sine x, and you put the bottom square. We're done with calculus. Believe it or not, this is the only calculus. So this is easy. We get x cosine x plus cosine squared. This one, a minus ba plus b is a squared minus b squared. So this is 1 minus sine squared. This negative remains. Distribute and change this to cosine squared. Remember, sine squared plus cosine squared equals 1. Change this, and these two cancel each other. Come up with the formulas. By the way, class, because sine squared plus cosine squared is 1, 1 minus sine squared must be cosine squared, so on and so forth. So I hope there's no problem. Everybody's comfortable with that. Exponentials, when the base is e and we want to differentiate, you always start with itself. The derivative of e to the power of x is itself, e to the power of kx is itself times k. So the way I do that, I'm going to say the answer is itself. Then I look at the exponent, I need a 5, and I'm done. Same thing for the next one, the answer is itself. Then I need the derivative of tan, which is secant squared, and we are done. Now the other one, we're going to rewrite it so it becomes clear. First, let me just rewrite this as e to the power of 2/3 x. So the answer is e to the power of 2/3 x, and times 2/3, which we put it in front. Okay. 3 to the power of x. When the base is no longer e, the answer is itself, and then ln b. So because an exponential, the answer is itself. You look at the base, is it e? No, therefore times ln 3. So 3x ln 3. And what about this one? The answer is itself, right, to the power of 7x. Is the base e? No, ln 2. By the chain rule, times 7, rewrite it, and you're done. But I differentiate this, and notice the numerator is just a number. So x squared plus 3 to the power of 1/2, bring it up, becomes negative 1/2. And now to differentiate this, we start with 4 times negative 1/2 times the same thing to the power of subtract 1, negative 3/2 in essence. The chain rule times the derivative of the inside, 2x. Negative 2 minus 4x. This goes down to the power of positive 3/2 or square root of x squared plus 3 quantity cubed. What about this one? We have to go with the product rule, f times g. So f prime is 3 times g, 3 to the power of x, plus g prime is itself, 3 to the power of x, the answer is itself, and then the base is e no times ln 3 times f 3x. Remember, this has exponent 1. So this is 3 to the power 1 plus x, or x plus 1. Same thing happens with these two. Okay. So if you factor 3 to the power of x plus 1, the first one gives you 1. The second one gives you whatever is left, x ln 3. We don't write ln 3x because one may think it's ln of 3x. Okay, so put the x in front. So what we did here, we used the product. Okay, before we use the extended power, we're going to ask ourselves, can I simplify? This gives me x, this gives me 4, and that makes life easier. 6x plus 4 to the power of 5. The derivative of the inside is 1. Rewrite it and you're done. What about part B? Extended power root 5 times the same thing to the power of 4. The derivative of the inside. Use the product rule. F prime 2 times g, which is x minus 8, minus g prime is just 1 times 2x plus 3, and put the bottom square. 2x minus 16 minus 2x minus 3. These two cancel each other, we get minus 19. So I'm going to just rewrite it for the following reason. I've seen sometimes students making a mistake with this, so I want to make sure everybody knows that 2x plus 3 has the exponent, and so does x minus 8. So the denominator becomes x minus 8 to the power of 4 plus 2. And this goes to the numerator, we get negative 95 to x plus 3 to the power of 4. We want to differentiate implicitly. Even if they don't say that, we have to do it implicitly. We notice the product rule for the first piece. We put the raised dot there. So this is 8x times y plus y prime times 4x squared. So I want to stop here. This is just the first piece. This one, we just use the extended power rule. Y is the same as g of x, so 4y prime is a number, is also 0. We're done with calculus. So that's pretty straightforward. We are going to move on. And notice we can keep these two because we have the y prime. This goes to the other side, becomes minus 8xy. This one, we take 4y prime out. We are going to divide. And simplify. What about this one? A couple of things I want to mention. Number one, the derivative of cosine is negative sign. The derivative of cosine of g of x is negative sign g of x, g prime of x by the chain rule. However, the way I approach things that, make it easy, at least for me, The moment I come across sinusoidal functions or trigonometric functions, cosine, I'm going to just pause. I'm not going to continue and say, okay, cosine, the derivative is negative sine. But any trigonometric function is meaningless without its argument. So I must use the same argument. And now the argument I want to differentiate. 12t cubed. This is the chain rule. I'm going to rewrite it and we are done. So that's pretty straightforward. I hope everybody's okay with that. All right, to differentiate this, first and foremost, tan is being raised to the power of 10. So I'm going to write tan of whatever this is, it's sine x cubed to the power of 10. So I want everybody to see that. And it means tan of some function, again, to make it easy to do this, because this will have a few steps. I'm going to call this some function. So I'm going to call this tan of f of x. So this is f of x. We're going to come back to the power of 10. And now I'm going to follow the fact the derivative of tangent is secant squared, and the derivative of tan of u would be secant squared u du dx. So this is being raised something. Okay, this is, we're going to use the extended power rule, is being raised to the power of 10. So we're going to go with that extended power rule. We start with number 10. Then we're going to raise this to the power of 9. And in fact, I'm calling it f of x, okay? And now I need the derivative of the inside, which means I need first the secant squared of, again, I'm not going to write sine x cubed. I'm going to go with f of x, everybody. And then I need the derivative of this f of x, which is f prime of x. So again, let's just say, okay, so we, in other words, just we used f of x here, okay, everybody? So a quick recap, 10, this thing to the power of 9, then the derivative of the inside. What is the derivative of tangent? Secant squared. And because tan is a function of x, the argument is a function of x times f prime x. Okay, so we are going to change f of x. Let me erase that. We are going to replace f of x with sine x cubed here. So we get 10 tan to the power of 9 of sine x cubed. We're going to change it here too. And everything is fine now. We need f prime of x. So if f of x is sine x cubed, let's differentiate sine of x cubed. So let's write this 10 tan to the power of 9 sine x cubed secant squared of sine x cubed f prime of x. From f of x, we're going to go to f prime of x. Sine cosine x cubed, the derivative of x cubed is 3x squared. This is done. We are going to rewrite. The way we're going to rewrite this, we're going to put these two together. We get 30x squared in the front with cosine x cubed, and then we write the rest of it. So 30x squared, cosine x cubed, tan to the power of 9 of sine x cubed, and secant squared of sine x cubed. That would be the final answer.